right, everyone, we are live. This is the first time I am live streaming from my PC. I usually use my Mac. I do also have a new microphone, so please tell me if the sound is working okay in the chat. Can you hear me? Can everybody hear me okay? That's great. Hello, AddOne and Sazid and Helicopter and Trubert. I'm not really sure how to pronounce your name, sorry. But that's great. Okay, so the sound is working. So today we are going to do some exciting experiment. Hello, Ayush. Welcome to the stream. So in some languages, primarily the functional programming languages, you can merge two functions together. So what do I mean by that? Let me put up my notepad and see if I can make this a little bit bigger. I hope you can see that text okay. If you can't, please tell me. So let's say we have two very simple functions. We have one which is called AddOne, which takes an integer as a parameter, and it will produce an output value which we'll call ret for return, and that will be equal to x plus 1. Simple stuff, right? And then we return this thing. Alright, so this is the one function. Then we have another function which we will call double. So let's say we take the same parameter and we will create a return variable as well. Let me make this a little bit bigger. And in this case, we will set this equal to x times 2. And then we return ret. Alright, so two very simple functions like this. But what I want to do is, providing these two functions, I want to merge these together. So we will create a new function and I will do this in pseudocode. So let's call that add and double. And that should be the same as having both AddOne and the double function. And as you all know, this is not possible out of the well, it's not possible in C as it stands right now, but can we make it possible? Can we go really low level and create this functionality ourselves? What do you think about this topic, chat? Do you think it will be an interesting endeavor? I hope you do, because I think it's an interesting experiment. And I think it might be possible, but we will see. We will not. All right. Hello, Anime KTM. Welcome to the stream. And hello, Santesh. Welcome. Yes, we can use function pointers, but a function pointer is just a pointer to an already existing function, right? So we can't really point a function pointer towards two different functions at the same time. We will, well, I have an idea in my head how this could maybe be possible to solve, and it involves function pointers, but it's only a small piece of the whole thing, so to speak. No notification. Isn't this just function composition? Yes, physicist, it's exactly what this is. It is just function composition, but since it's not possible to do function composition in C, I still think it's a pretty interesting topic. Hello, Arun. No notification. Well, we haven't really started yet. It's weird that you didn't get a notification. I did send it out as I usually do, I think. Well, you haven't missed anything. The only thing I told was that I will have one function which adds 1 to a number, another function which simply doubles the input argument, and I want to mash those two functions together like function composition. So I want to create a third function at runtime. Let's call it add and double, and it should add 1 and double the number. And this is possible in functional programming languages, but there is no built-in way in C to do this. So let's see what we can achieve. All right, shall we begin? Let's do it. And let's see. I hope this is big enough for you. Perhaps I can make it a little bit bigger because the black background and the white text might be a little tricky to see. Let's see. Where is here? What about 14 and fat? Like so. All right, I hope this is visible. If it's not visible, you can tell me in the chat. Hello, Saxam, welcome to the stream. And I will check the chat from now and then and see if we have any questions. But we will begin the actual thing now. So, how do we achieve this? Well, I have a general idea how we can do, let's see, let's create a folder for this project. I will set my home to this merge folder. All right, so what we need to do is we need to create an empty function. So in order to fill a function with the content, we have to be able to create an empty function. So what is an empty function? Well, let's see if we can create an empty function in C. So let's just create a simple main which returns 0, and then we will create something which resembles an empty function. So it will be a void return value because, well, we don't want to return anything if we want it to be as small and empty as possible. Let's call this empty and let's not take any parameters. And let's just return without doing anything. All right, so this should be an empty function. But what does this compile into? So let's do something like this. make sure that it runs. And then I will use the objdump utility program in order to check what assembly code this function becomes. So let's pipe this to more, and let's go to our empty function. Let's do it again. Empty. Alright, so this is our empty function. So this is basically what the most functions contain. It's some kind of prelude, or something that is in the beginning of every function. This basically sets up the stack frames and memory and stuff, so the function can run properly. And then we will have an instruction. In this case, it's a no-op. A no-op instruction basically means do nothing. And then we will have some kind of ending, which in this case does the opposite of this to get the memory in order. And then it simply returns back to the function that called this function. And if you look to the left here, we will have the hexadecimal binary values of the assembler instructions. So basically the machine code. So we need to take this 5589E5 and put it in the beginning of our empty function. And we need to take this 5DC3 and put it at the end of our empty function. And we will fill up the between with those 90 instructions. Are you with me so far, audience? Let's see. So amazing to make video on cybersecurity tool. Yes, I will most definitely make a lot of cybersecurity episodes this year. Hello, Joseph from Spain. Welcome to the stream, and welcome also Jogendra and Rajip from Germany. Service from Germany. Welcome to the stream. So let's see if we can achieve creating an empty function. So let's go back to our code and remove this thing. And let's see. Let's save those values, by the way, that I got from the objdump. Let's see, empty. Let's just take this whole thing and put it inside of our notepad. And let's divide this up a little bit so we have the thing in the beginning, the pre, and the thing at the end, the post, and then we will have a lot of no-ops in the between. So let's take let's do this. We go here and let's we can create a definition, or not a definition, let's do a global variable. So let's say we have type def unsigned char, which we'll call int date, just so we have some kind of a variable type to work with. And we'll create a pre, which will contain the hexadecimal value 55, 89, and E5. And we will create, let's see, we will create a post which will contain the 5D and the C3, like so. I do also want to have the length of these. So let's create the definition, which we will call pre-len, for the length of the pre. And this will be equal to, let's see, size of pre. And we will define post-len equal to size of post, like so. Alright, so let's create a function which we'll call empty, and it will return an int 8 pointer, empty, and it will not take any arguments. Let's make it take arguments. Let's take it can take a size, so we can define how big of this function should be. So let's do, I think I want to include my Birch utils library, and if you want to get this library, you can just go to our repo .drbirch.com and go to the Birch utils, and this is v1.3 that I'm going to use. It's just a small library with some utility functions that I use from time to time. And let's include some other stuff as well, so we can use a little bit of standard C functions. I also want to include the Birch utils.h. I want assert.h, so I can make assertions and don't have to worry too much about the error handling. And I also want our number, and in order to get all the functions I need, we'd need to define GNU source. Alright, now we have some stuff to work with, and I can remove this because I have it inside of Birch utils. Alright, so empty function. I will make an int 16 size, and let's see, we need a pointer, and we need to, let's create a common length as well. This will just be called len, and this will be equal to the size, it will be equal to the pre-len plus the post-len. So this is the overhead. Maybe we should call it overhead then. So our function needs to have at least these bytes of size. So let's assert that the size is bigger than or equal to the overhead plus 1, let's say. So if it's not equal to that, we will fail. Alright, so let's see. Now we want to malloc size bytes of memory, and let's zero out that memory segment. Alright, so if we give it 64 bytes, for example, we will zero out the whole space, and this will be a little bit of cookie over cookie, as we say in Sweden. It basically means that we do stuff all over again, but don't mind that. Alright, so let's see. I want to memset let's create my little annoying aliases as well, because I need to do a lot of conversions between different variable types. So I like to have stuff like this. So I can use $1 instead of the cast to int8, and so on and so forth. I will not create all the ones that I usually use, but at least a couple like this, because now we can simply do $C instead of that thing which is difficult to type. Alright, so we will memset p. Let's see, I want to memset it with 0x90, and if you wonder why it's 0x90, that's because we want to fill up the entire space with no ups, right? And we will use the size of that. So now everything is this 90 stuff. Now I want to copy this string to the beginning of the mem space. I think I want to do this, by the way, to make stuff a little bit easier. Let's remove one from both of these. And let's see. So now I want to mem copy into the beginning of the mem space, which is p. I want to copy the pre. And we'll use prelen, like so. And at the end of the space, I want to copy the other one. So we need to do a little bit of pointer calculus, or whatever it's called. Let's create an int 16 to make things a little bit easier. So let's see. If we have, let's see, we will set n equal to, let's do it in one go. We will mem copy into p plus the overhead. No, p plus size. Then, so now we're at the end of our mem space. Then we want to go back one step. So we're at the last character. Let's do minus postlen. I think we're at the right place. We need to check this afterwards. Okay, so at the end of our main mem space, we want to copy the post, this string, and we'll use the post length, like so. Let's also assert that we actually have a mem space. And then I think we are done with our empty function. So then let's return p, like so. And let's make some room. Alright, so how can we test this? We can do something like this, int8 p, and we will create an empty function. Let's make it 64 bytes. And then I want to print hex. The p 64 bytes and no separator. Print hex is, by the way, a utility function from the BERT-utils library. It just print some portion of the memory in hexadecimal numbers. And let's be proper and free this mem space, and then we'll return 0. Alright, let's see how many errors we have. So we'll compile this thing, and let's remove all optimizations, because we want to have maximum control over this thing, and we need to include the BERT-utils library. Oh, that's a lot, but probably there's some annoying error in the beginning which causes all this. Yeah. There should not be an equal sign. Alright, let's try this again. Alright, a little better, I think. Oh, I changed the wrong thing. It's not easy to live code, right? This is what we should remove, right? Okay, that's better. Implicit declaration of memset, alright? We need to include string.h, and it compiled, alright? Does it run without crashing? Yes, it does. Alright, so what do we have here? Let's take this thing and put it inside of Notepad. Alright, so in the beginning we have 5589 E5, which is exactly what we were looking for. Then we have a lot of these 90, 90, 90 no-op operation. And at the end we have 5D C3. 5D 3C. Okay, so we have exactly what we wanted. This is our empty function. Are you with me this far? Chat, any questions? Oh, let's see. Do you work in the assembly level? Do you plan to make project using assembly? Well, I work with YouTube and I code assembly right now, so in a way I work with assembly. Do you plan to make a project using assembly? I have actually done a couple of projects using assembly. My most notorious one is the runlock project, which takes any Linux exe file, so to speak, so an ELF binary, and it adds a password protection to it, a secure, basically uncrackable password protection, by encrypting the entire thing in memory and decrypting it live while executing it. So if you like assembly, you should definitely take a look at my runlock project. It is really groundbreaking stuff. I have also done a series of assembly school. If you look at my Twitter or my YouTube. Let's see. Hi doctor, been using the Sociopath software for a period, really convenient tool. Thank you, Jim. Yes, I am very proud of my Sociopath project. For you who doesn't know what it is, it's SCP client. So SCP is a secure copy which is built into the SSH program, or the server software. And it basically makes, well, let me show you. So let's launch this thing. And So this is how it looks like. On the left here, it's my local machine, and on the right, we can connect to any Unix, Linux server, and we can transfer files, and we can also edit files in VS Code, for example, live, and it will update when we save. So that is one of my most ambitious projects. Hold up, isn't the define directive not supposed to have the equal sign? You are exactly right, physicist. That was one of the errors that I had to fix. How can you code in a terminal like that? Well, when I create bigger projects, I usually use VS Code. But when I need to do stuff on the fly, so to speak, I usually code in VI, like I do now. And if the question is how can I code in a window like that? Well, I am connected to my Linux server, that's why. So everything I do in here is actually on a Linux machine which is called Intel 32. So I'm connected using the PuTTY software to this Linux machine, and that's why I can do it. Been watching since the first day. Keep up the good work. Where are you from? I'm from Sweden. Hello, Roaster. Welcome to the stream. I'm very glad to have an old timer in here. And I'm very glad that all of you are here. Learning DSA using C, your thought. Yeah, I think C is a very good way to learn how data structures and algorithms are used low level. And hello, Yash Raj. Sorry for my pronunciation. Welcome to the stream. Let's see, how many are we? 27. That's not bad. Any questions this far with regards to the project we are working on? So at this point we have created an empty function, and our next step will be to see if we can execute this empty function without crashing. Happy New Year, Hilton. This code is like creating a Perl/like shellcode overflow function. Well, something similar actually, yeah, because a shellcode is basically machine code which is being run in memory, and we are creating machine code which are being run in memory. So something like a shellcode. Yeah, I think this is similar. I'm currently in Europe and I graduated a couple of months ago. Now I'm a student, freelancing is easy and possible, but well, hello Roaster, welcome to the stream, and hello Abhishek. Happy New Year to you as well. How can you find opportunities? Luxembourg, Germany, Sweden, not LinkedIn, and those stuff. Well, one way is creating a lot of different projects of your own and publishing them online in some kind of repository, or creating a website advertising yourself. I think that's a good way, but I'm probably not the best guy to ask about career advice, since I don't have an employment myself. YouTube is my workplace. I recognize the prologue and epilogue functions. That's why I asked. Lol, thanks. Yeah, it's similar actually. All right, let's keep this on. Let's see if we can execute this empty function that we created. So how can we execute a function on the fly out of the memory in C? Well, we will use function pointers. And I always seem to forget how the syntax in C is for function pointers, but let's see if we can figure it out. I want to create a function pointer called f. So something like this. And where do we put the additional parentheses? I think we put them like this, right? I think this is the right way. And in order to point it towards memory space, we need a void as well. So let's see. We will do mem. Let's comment this print hex thing out for now. So we will point the mem space to our p, which is our empty function, and we will point our f function towards the memory space. And then we want to execute f. We will call the f function like this. And since the function doesn't do anything, how do we know that it works? Well, this will crash a lot if it does not work. So that's how we know. Let's see. Right, we need to compile it the same way as I did before. So where did we have the compilation? Here we do. Okay, it compiled. Let's see if it runs without crashing. It did. Nice. All right, so we can also do an strace on this possibly. And let's see what happens. Well, it doesn't do much, which is good. And if we do an ltrace, we will only see the setting up stage and the freeing stage. We will not see much otherwise. All right, but now step one is complete. We have managed to create an empty function on the fly, and we have succeeded in executing that without crashing. So, but we want to merge two functions together. And in order to merge functions together, we will have to extract the essence of a function. And what is the essence of a function? Well, if let's create that example function that I was talking about before. So let's say we have an int AddOne which takes a parameter x. It creates an intermediate variable ret, which is equal to x plus 1, and we return ret like this. So I want to extract the essence of this one. Let's comment out this stuff for now. And let's just call AddOne, and let's give it a 5, for example. So we compile this one, and let's do an obj dump on this thing. And let's find our AddOne function. So this is our AddOne function. In the beginning, we have this prologue, which is the same as we had in our empty function. And at the end, we have this same ending, basically, It's a little bit different in this case. Let's see. Yeah. This leave instruction is actually very similar to this pop EBP. It's just a different way of doing stuff at the CPU level. But the interesting thing is the thing in between. So this is the essence of the function. This is, or maybe we shouldn't include this first line either. This is what makes this function what it is. It moves the argument in place, it adds 1 to it, and it returns that value basically. So no matter what function we give as an input function, we want to extract this part of it. So we don't need this prologue, we don't need the epilogue, we want what's in between. All right? So we want to take everything from the beginning of the essence of the function, so this, and until we encounter C9 and or C3. So let's save that stuff. C9, C3. And this stuff we already know. Shall we include this one as well? I think we do. So let's alter our prologue and epilogue a little bit. So let's see, x55, x89, xe5. Yeah, I want to add this thing. Because we want to set up our stack frame properly if we are going to be able to use arguments and stuff. So let's add this to our prologue. And our epilogue should contain this other stuff. So let's see, where were we? We had our AddOne function. So let's see, this move instruction at the end here. I think I want to include all these things actually, because what this is doing is basically returning the value. So let's take this and this, and then C9, C3. So this will be our new epilogue, and let's do something like this. We go inside of here and paste this. Let's add space, and let's just change all the spaces to this to make things a little bit easier for us with some VI magic. Right, this will be our new post. Alright, it's growing a little bit. Let's see, by the way, that it still does not crash, because we are messing around a little bit with stack frames, and that sometimes messes things up. So let's comment out this sorry. Let's comment out this AddOne, and let's see. Let's let's not free this, let's just do an exit instead. Alright, we'll try this. Will it crash? No, it did not crash. And what return value do we get? Echo dollars, question mark, 0. Okay, looks good. Looks really good. And how, if we want to print this thing out, will it still look right? So we have our new prologue, and then we have all of those no operations all the way here, and then we have our new epilogue. Yeah, sounds good. Alright, so let's extract everything but the things we are interested in. So let's see. I want to create some kind of function. Let's make it a void, and let's call it FindEnd. And it will take a mem space as an input, which is basically the function that we want to pass into this. And we want to look through it and find that ending, that C3 or C9, if you remember. So how do we achieve this? Let's create an int8 pointer, and let's create an integer as well, because if in case we do not find that ending thing, we don't want to loop forever. We want to have some kind of maximum. Let's say 1024 bytes or something. Alright, so let's do a for loop. We'll set p equal to the function, and we'll set n equal to 0. We want to loop as long as n is less than 1024, let's say. And at each iteration we want to increase p, we want to increase n. And at each step we want to check if the thing that p is pointing towards, is it equal to C3, or is it equal to C9, I think it was. And if that is the case, what do we want to do? Well, let's define an additional variable. Int8, let's call it, or let's make it a void, and let's call it end, and let's set that end function equal to p, but we want to back up one step, right? Because if we find the ending, we don't want to include the ending. We want to find the last instruction of relevance to that function, basically. So that will be p minus 1. And then we want to break out of the loop. Think something like this will work. And then we can simply return the ending, like so. Alright, so let's see. Well, let's try this thing. Let's define some kind of variable, void foo, and we want to set foo equal to find ending, I think I called it, or find end. Find end. And we want to pass in a function here. So we have this AddOne function. Let's send that. And let's print the result. So address of AddOne function. And then we want to print that address. So it'll be 0x% like this. And then the address of, maybe we need to do unsigned int, and then the address of AddOne. And then we want to print ending address. So this should be somewhere around that function's address, but a little bit more. Then we know it's right. So let's see. We will give this the... No, we don't want to point F towards this. We want to point, let's see, foo should be equal to this. And then we want to print out the unsigned int of foo. I think this is correct. We will see, won't we? Let's compile this thing and let's run it. Okay, what do we have? So we have this address. This is the address of the function AddOne. And this is the address of the ending of that function. So these should be pretty similar, but not identical. So let's see, all these fields are equal and this is different. Yeah, seems right. So basically, if we take a look at this objdump output again, and we find our AddOne. So we are searching through this function. When we find this C9, we back up one step, and this is what we are pointing towards. So now we have successfully found the end of the essence of this function. Now we want to take the beginning, so everything but the prologue, and basically from here, and we want to extract everything in between, right? Are you with me so far, chat? Let's see. LD preload. Yeah. Let's see. Thanks for the advice. Happy New Year. Happy New Year energy. Hello, Shirillos. Welcome to the stream. How many are we? 30. That's a new record, I think. Maybe. Something around there. All right. So we have successfully found the end of the function. Let's create something which extracts the essence of a function. Let's call this, this will be a void, and let's call it extract. And we will take a function as an argument. And how do we do this? Well, first we need to find the ending. So let's begin there. We'll set end equal to FindEnd of the function we pass in. And maybe we need to start creating some function definitions. So what do we have? We have a void FindEnd, which takes a void star, and we have an int 8 empty, which takes an int 16. We have an int main, like so. What else? We have an int AddOne int, and the thing we are creating currently is void extract, and it takes a void star. I think we got it all right. And maybe we should switch to VS Code because it's getting a little bit messy inside VI, I think. So since I'm coding remotely against a Linux machine, I need to use Sociopath. So let's do it. I want to connect to this one. Yes. It expired. That's a little bit annoying. Alright, that's right. It's a new year, and this version is only for the to the year out. Well, let's do something like, let's do this. If I go to Code Planet and I go to Code Sociopath Web Public and release, and I think I will have this one. So HTTPS W2 Sociopath and this. No. Release. Now my cat is getting anxious. No looks. Don't. Alright, so let's see. Sociopath, really, maybe not sociopath. Just like this. There we go. So let me just download this Pro version, which does not have any limitations. And this Sociopath project, by the way, will be open source pretty soon, sometime around, the first half of this year, I'd say. More info on that later. Alright, so let's install this thing. And I'm having too many windows, I think. Here we go. And it's a very fast installation program, so don't worry. It'll only take a couple seconds. There we go. All right. So let's see. It remembered my server IP. All right, now it works. So let's go to the where were TMP, I think, and merge, and I right click and open in editor. So I can open the entire folder in the editor, and it will download all the code files, and it will open the folder inside of VS Code. So here I have the code, and maybe I should change to black instead of white. If I remember how to do that. Theme. Color theme. And I want the light. Where is dark? Dark. Which is the default? Default dark. Here we are. All right. I'm using white background when I code Haskell. That's why. All right. So let's see. This is the code we do have, and where were we? We were about to code this extract function, weren't we? So we have found the ending, and the beginning will simply be the beginning of the mem space plus the pre, right? The prologue. So let's see. We will define a, let's see. Well, I want to do something like this. Let's do int 8p, and we will set p equal to the function plus the prelen. Think that will get us right. And then let's do this, by the way. So this will be our start. And P will be a memory allocation. So P will be equal to malloc. And how much do we need? We need to calculate how big this memory space should be. So let's create an int 8 size, and the size will basically be equal to the end minus the start, right? That must be how many bytes we need. So let's put it inside of here, cast it as an integer, and let's assert that we have a p. Yeah. And I like zeroing stuff out before I use them. But then we want to copy the essence of the function. So let's copy, let's see. We want to copy into our memory space P. We want to copy from the start, and let's cast all this stuff to int 8 instead. So this will also be an int 8, and we want to copy size bytes, something like that, and then we'll simply return p. But we need to return a void, so let's do this. Void ret. I will set ret equal to p, and we'll return ret. Alright, I think this will basically copy the essence of the function. Let's see if I am correct. We need to test this. Maybe we don't need all of these. Delete until end, like so. Alright, so where were we? Yeah, we can remove these things. This, can also remove foo. So what do we want to do? We need another void. Let's put foo back. And let's say foo is equal to, and we want to extract the essence of the AddOne function, right? And let's do, but it's not simply enough to just extract the data. We also need to know the size of it. But how can we return both the data and the size? Well, we need to create a tuple, won't we? So a tuple is basically two variables returned at once. And there's no support for that in C, so we need to create it ourselves. And I think that will be pretty easy, actually. So let's see. Let's define a structure. We'll call it S-tuple. And it's pronounced tuple, by the way. It's not pronounced tuple, because Jupiter is not pronounced Jupiter. If it were to be pronounced tuple, it would have two P's. So struct S-tuple will be let's call this we'll have a void address, and we will have a int16 size. That's our general structure of this, and we want to type def struct S-tuple, and we will call it tuple like this. Let's change the signature of this extract function. It should return a tuple instead. And let's see. So our ret should be a tuple. Or maybe we can make use of this new C feature and do this instead. I don't generally like to define a variable and assign it a value at the same time, but since that is necessary for this technique, I will do it this time. So we'll define ret, and that should be equal to, we will have an address which will be equal to p, and we will have a size which should be equal to size. This will be removed. Yeah, I think that'll do the trick. So let's go to our main, And let's change this foo into a tuple. Foo will be equal to extract AddOne. And let's print out the size. And the address. So this will be foo.address and foo.size. And we probably, no, it's the other way around. And we probably need to cast this to an integer and this as well. And after that we will print hex. And we want to see what we got from this extract operation. Something like that. And we probably need to cast this to an int 8. Like so. And now I saved right here. If we go to Sociopath and you see right here, the file has changed, successfully updated to server. So it will run in the background and it will update to the server as we progress. So let's see, I want to go back into my Intel 32 machine. Get back into my screen. And let's compile this thing. Alright, conflicting types. Thought I changed that, but perhaps I didn't. Let's see. That looks right. Oh no, I didn't change. No, I didn't. So this should be tuple as well. Right. Let's try this again. Okay, too few arguments. That's right. We need to give it a separator as well. Let's use nothing. And it's compiled. All right, let's see what we got. Did I leave some old stuff in here? Yes, I did. Let's remove that. All right, so 11 bytes is the essence of the AddOne function according to this program. And this is the start of it. No, it's not. A memory address should not look like that. I think we need to do this, right? Yeah, I think so. Yeah, that looks better, I think. No, I don't. It was right before. One should never question oneself. I just thought the memory address looked a little bit weird, but sometimes when we're dealing with a heap, maybe. Doesn't matter. This is the important part. Starting with 8B45, etc. Let's put this inside of here. And let's see if we got the right thing. So let's do an obj dump again and find our AddOne. And this is the thing. Let's put it inside of here. Let's make it a little bit smaller. All right, so it starts with 8B45. 8B45. No, this is probably a 0 in beginning, right? No? Here it is, 8B45. All right, so the thing we don't have is this, and that's exactly what we were looking for, right? We wanted to remove this thing, and we wanted to grab this 8B all the way to 45, to 8B45, so here. But we also want the FC, don't we? That little rascal got away. We can't have that, can we? So let's see how we can fix that. The ending is basically too narrow. Let's add one to it. Let's try this again. Now we have this string. We will put it inside of here. All right, so 8B45FC, 8B45FC. We go all the way here. So this is the essence of the function. This is what makes the AddOne function, basically. And then we will have this ending right here, C9, C3, and also this, by the way. 8B45 FC. Okay, so we do include this. Yeah, that's okay, I guess. (8945FC) 8B blah 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 blah. All right. Okay, so the next stage is, let's see if there are any questions, by the way. How many are we? 16. Oh, we lost a couple. All right, so let's see, will this be on YouTube? Yes, it will be at one point, but probably not for a couple of weeks. I'm not sure. Depends on what I'm gonna publish in 2 days. But I want to do some post-production and stuff on this episode before I release it, as I usually do. Let's see. Okay. What is OOP? I was things is a function. That's funny. Cannot use your own tool. No, that's right. Hello. I wish I had 10% of your knowledge. Thank you. That's very kind of you, Amit. I think you probably do, but yeah. Can I get this thing? All right. What's up? How did New Year's Eve go? Well, it was pretty soft, I think. Not much of a party, actually. Casting it as an 8-bit integer is for optimization performance of the memory allocated. No, it's for convenience, more likely. Since most operations inside of C is being used on 1 byte units of memory, casting it as an int 8 makes things a little bit easier, I think. Hello, Ramp Rowdy. Welcome to the stream. I got, correct me if I'm wrong, but the cast is because you're extracting just values of the opcodes, right? I'm trying to think. Well, the casting is because since I'm using this int8 stuff everywhere instead of regular integers, I have to do a lot of casting because most functions like malloc does not take an int8 value like the size is, or an int16 in this case. It takes a regular integer. That's why I need to cast it. And since I do this many casts, I will have these aliases, these macros. So it makes a little bit easier. Please tell me some good resources to learn and practice data structures. Well, I think you can check out my my episode about a linear search algorithm, I think it's called. You can also check out the hash table episode and the binary tree episode. Tinkering with stack frames, I say. Hello everyone, Happy New Year from Germany. Happy New Year to you too, linear, non-linear. I remember your nickname from the comments. And hello Eduardo, welcome to the stream. Can you implement a generic hash table that uses the hopscotch methods to solve conflict? Well, I have created an episode where I create a hash table where I use my own algorithm to solve the conflict, and you should check it out. Alright, so as the next step and as the last step for today, I will try to put everything together that we have this far. So basically, I want to create an empty function using our empty function. And I want to add the essence of the other function to it. And how do we do this? Let's comment out this whole main thingy. Like so. And let's create a new main. And let's create a couple of variables. An int8 fun, let's say, and a void let's see, let's call it essence, and we'll set fun equal to an empty function of size 64 bytes. Then we extract the essence of we need to make this a tuple. And we'll extract the function AddOne. Then we want to memcopy into our function the prologue. Let's cast this the same, and we will have the prelen. Maybe we can do this with two variables. It makes things a little bit easier. So we will set p equal to fun, and we'll copy this to p instead. and then we will increase p by the pre-len, and then we want to copy the essence. So into p we want to copy the essence dot address, and we want to copy the essence dot length size, and then we'll increase p the same way by essence dot size, and this should be an integer. So now we have copied the essence. Now we want to copy the ending stuff. Or do we really need to? When we create an empty function, we already have the start and the end, right? I forgot that. So let's skip this step. So we have this thing, and p should be equal to fun plus pre-len. Then we copy the essence, and then we already have the ending, right? So now we should have our function, I think. Let's create a function pointer, and this time this will be an int f int. We'll point f towards let's see, we need to do a void in between. So the mem is equal to our function, and f is equal to our mem, and then we run f with 5, let's say, and then we exit. Alright, let's see if this works. Then we are done for the day. So let's compile this thing. And if it does not crash, it works. And it does not crash. Ladies and gentlemen, we have created a function on the fly in C. So the only thing we have left, or only thing, it's quite a lot of things, but is mashing the functions together and handling the return values and such. And that will be in the next live stream. So what do you think, ladies and gentlemen? Did we achieve some victorious result today? Let's see. See a lot of talk about Raylib. I have also heard that it's a good library, but isn't it backdoored? Maybe, I don't know. Alright, I think this is it for today, guys. I hope you are satisfied with the content. Thanks for watching, and thanks for today.